All right, so I've had a few of you ask to record a video going over some of the questions on the review. So what I think I'm going to do, I'm going to go over each question. This really isn't a video that you should be sitting through start to finish. You should be trying to do the review questions on your own. And then when you get stuck, find that question on the video if you need to get a little bit of guidance on it. All right. So first group of questions is all about theoretical probability. So this first part A, the theoretical probability that a spinner stops on a multiple of 3. Remember, theoretical probability is what should happen. So when I look at this spinner, there's 10 possible numbers that the spinner could land on. So that's going to go on the bottom. 9 of those numbers are divisible by 3. The only one that's not is that 4. So there's a 9 out of 10 theoretical probability that I get a multiple of 3. If I spin the spinner 30 times and it stops on a multiple of 3 20 times, what's the experimental probability? And this one has been getting people confused all day long. And it's easier than you're making it. If I spin the spinner 30 times, that goes on the bottom. That's how many times I did the experiment. On top is how many times I got whatever it's talking about. And in this case, it's talking about a multiple of 3, and it got that 20 times. So my experimental probability is just 20 over 30. Part C asks for an explanation of why these are not the same. And really, it's a simple explanation. 9 out of 10 is what theoretically should happen. That doesn't mean it's guaranteed to happen when I actually do the experiment, especially if I only do the experiment 30 times. Okay. Part D says you spin the spinner 60 times, it stops on a multiple of 10 6 times. How does the experimental probability compare to the theoretical? Well, stopping on a multiple of 10, there's only one of those, the number 30. So theoretically, only 1 out of 10 is a multiple of 10. Based on the experiment, I got 10 of those. Nope, I didn't. I got 6 of those. I got 6 multiples of 10 out of 60 spins. And it wants me to compare these two probabilities. Well, if I divide this one, I get 0.1. If I divide this one, I also get 0.1. So these probabilities are actually equal in this case. All right. We're going to go over to these odd questions on the right-hand side. And I don't mean odd numbers. I mean questions about odds. So number 19 wants us to use the same spinner, but it says, what are the odds in favor of stopping on a multiple of 6? Now, odds are a little bit different. So the way that I do odds is, first of all, it's in favor. So I count how many are multiples of 6. So there's 1, 2, 3, 4, 5 multiples of 6. And then I don't put the total. That's not correct. What goes after the colon is how many are not multiples of 6. So that would be this one, this one, this one, this one, and this one. So it would be 5 colon 5. The odds in favor are 5 to 5 is the way that you say that, okay? The odds in favor of stopping on a number greater than 10. So I'm going to count the numbers that are greater than 10. So 12, 15, 16, or 18, 21, 24, 27, and 30. So that's 1, 2, 3, 4, 5, 6. There's 7 numbers greater than, I'm doing the wrong problem, greater than 10. And there are 3 numbers that are not. So the way I write the odds are 7 colon 3. Remember, odds and probability are different. The probability of getting a number greater than 10 would be 7 out of 10. But the odds in favor are 7 colon 3. So you got to be really careful that you write these questions appropriately. Against stopping on a number less than 9. That's kind of like saying not getting a number less than 9. So when I look at my spinner here, if I count the numbers that are not less than 9, So that's counting the numbers that are 9 or bigger. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them that are not less than 9. So there's only 2 that are less than 9. So against or not against stopping on a number is the same as not stopping on a number. So the odds are going to be 8 to 2. Against stopping on a number that is divisible by 7. So dividing by 7, there's 21. And I think that's the only one. So there are 9 that are not divisible by 7 and only 1 that is. So 9 to 1 would be the odds. Okay, number 23. We're kind of on this odds roll, so we'll keep going. The odds of winning a lottery game are 3 to 5. The probability of winning a bingo game is 35%, which gives you a better chance. It's hard to answer that question when one is written as odds and the other is written as a percent. So the one that's written as an odds of 3 to 5, that means the odds of winning are 3 out of, if I want to write this as a probability, I can't put 5 on the bottom because I have to put the total number of possibilities on the bottom. And there's 3 chances of winning and 5 chances of losing. So that means there's 8 total chances. So I'm going to put 3 over 8. And then 35% is just 35 over 100. So it wants you to compare these two numbers and then explain why you picked the one that you picked. So you just divide them. You get 0.375 here and 0.35 on the second one. So that means that the odds of winning the lottery game are higher than the probability of winning a bingo game. So you have a better chance of winning the lottery game because the percentage is higher. Okay, 24. Probability of winning a carnival game is 1 out of 4. The odds of winning a raffle are 1 out of 3. Same idea. I'm going to let you do that one on your own. It's going to look exactly like what we just did on number 23. All right. Okay, going down to number 1. You randomly draw a marble out of a bag containing 8 greens, 4 blues, 12 yellows, and 10 reds. I'm just going to start writing it down as I read it. Find the probability of drawing a marble, that's not yellow. Not yellow is the key word here. So when I look at this list, those are not yellow, those are not yellow, those are not yellow. So when I add those together, that's 22 marbles that are not yellow out of 34 total marbles, because I have to add the 12 to get the total number of marbles. Okay. Number 5, you roll a 6-sided die 30 times. A 5 is rolled 8 times. What's the theoretical probability of rolling a 5? What is the experimental probability of rolling a 5? Again, an easy question that you guys are making much more difficult than it is. Theoretical probability of rolling a 5. Theoretically, what should happen? What is the chance that I roll a 5? Well, there's only 1 5 out of 6 sides of a die. So my theoretical probability is just 1 over 6. My experimental probability is the results of the experiment. And I did the experiment 30 times. So that goes on the bottom. And I got a 5 8 times. So that goes on the top. So my experimental probability is 8 out of 30. My theoretical is 1 out of 6. Simple problem. Don't make it harder than it is. Number 6 says you randomly draw 1 card from a standard deck of 52 cards. What are the odds that it is a diamond? So it wants the odds of getting a diamond. Well, there's 13 diamonds, and then there are 39 not diamonds. So the odds would be 13 to 39, which you could simplify to 1, not 1 to 4. That's a 1 to 3 odds there. What are the odds that it is a 7? Well, there's 4 7s in a deck, and there's 48 other cards. So it would be 4 out of 48, or 1 to 12 odds that it's a 7. Okay, number 7, events A and B are independent. Find the missing probability. So for both of these questions, you are using this formula that says the probability of A and B is equal to the probability of A times the probability of B. The difference is in number 8, it's a dependent event. So instead of probability of just B written that way, it would be written the probability of B given A. It would look like this. So if I plug in what it gives me to my equation right here on number 7, the probability of A is 0.25. Well, that goes right here. The probability of B, I don't know. That's my X, so that goes here. The probability of A and B is 0.05. So all I have is an equation with an X that I don't know. And you guys know how to solve for X. You do railroad tracks. 0.25 times X means I need to divide by 0.25 on both sides, and you're going to get your answer. Number 8, it gives me different pieces of the formula. The probability of A and B equals the probability of A times the probability of B, given that A already happened. So it gives me probability of A, which goes right here. It gives me probability of B given A, which goes right here. So in order to find this piece, all I have to do is multiply those two together to get my answer. So make sure you have that formula down. Again, I'm going to let you do the math on your own now that you know how to do it. You roll a 6-sided die, a red 6-sided die, and a blue 6-sided die. Find the probabilities. This notation is going to be important. The probability of getting a, remember that P means probability, and whatever is inside is what you're finding the probability of, right? So probability of getting a red odd and a blue odd. I remember that and means I'm going to multiply something. And all I have to multiply is the probability of the left side times the probability of the right side. So red odd. So the red die has 3 odd numbers out of 6 numbers. A blue odd, the blue die has 3 odd numbers out of 6 numbers. So I do 3 over 6 times 3 over 6, which gives me 9 over 36, which will simplify. But again, I'll let you worry about that. So what's that going to be? 1 out of 4 is what it's going to be. So never mind. I'm not going to let you worry about it. I just did it for you. Number 10, probability of red and blue both being less than 3. Again, that and means I'm going to multiply something. So I want red to be less than 3. Well, there's 2 numbers less than 3 on a dice, on the red dice, and 2 numbers less than 3 on the blue dice. So 2 over 6 times 2 over 6, that equals 4 over 36, or 1/9 is what that one's going to simplify to. Probability of a red 2 and a blue greater than 1. Now, here's what a lot of people have been doing, and it's wrong. This red 2, they keep writing as 2 over 6 because they see the 2 and they just think 2. But the probability of getting a red 2, there's only 1 2 out of 6 sides of the dice. And I'm going to multiply that because of this word and by the numbers greater than 1 on the blue dice. And there's 5 numbers bigger than 1 on the blue dice. So 1 over 6 times 5 over 6 is 5 over 36. Analyze relationships. You select 3 cards from a deck of 52. What's the probability that all 3 cards are face cards when you replace each card after selecting it and when you do not replace each card? So I've got to consider 2 different situations. One is with replacement, one is not. So let's do with replacement first. Face cards. There are 12 face cards out of 52 cards in a deck. So if I pick one and I'm going to pick another one, but I put the one I already picked back. So there's still 12 face cards out of 52 cards. And then I put it back and there's still 12 face cards out of 52 cards. So I'm going to multiply those 3 things together and I'm going to get some number. I don't even know what it is. So that's if I replace it. If I don't replace the card, my first choice, I've got 12 out of 52 chances of getting a face card. But when I pick my second card, there's not 12 anymore. There's only 11 cards out of 51 because I picked a face card, which made the faces go down and the total cards go down. Then I'm going to pick a third card. Well, there's only 10 face cards left out of 50 total cards. So you multiply those three together to figure out the probability if you don't replace a card. Okay? Same question here for number 20. I'm not going to go through number 20. Apply the same reasoning with marbles. Okay? What's the probability if you put the marble back as opposed to if you don't put the marble back? Make sure you know the difference between those two. It will be on the test. All right, we'll call this 13. I don't know what number it is because it's not written down. We'll call it 13. So you've got this table talking about locations. I don't even know what the locations mean. And if someone, it looks like if they're satisfied, yes, or if they're not satisfied, no. So it asks me, what is the probability that a randomly selected patient located in Saratoga? Well, that right there limits my group. It's not asking me what's the probability out of everyone. It's asking me that a random selected patient in Saratoga. So I'm not looking at everybody. I'm only looking at people in Saratoga. So when I look at this chart, that's this column right here. Those are my Saratoga people. So on the bottom of my probability, I'm going to put 0.288 plus 0.077. That's going to go on the bottom because those are all Saratoga people. It asks what's the probability that someone from Saratoga is satisfied with the communication of their physician. Well, when I look at this chart, Saratoga people that are satisfied is listed right there. So I'm going to put 0.288 on the top. And when I put that in my calculator, again, I'll let you do that one. Part B is similar. What's the probability that a randomly selected patient who was not satisfied? So it's not asking me to choose out of everybody. It's only asking me the not satisfied people to go on the bottom. So I'm going to take all the not satisfied people and I'm going to add those together. 0.042 plus 0.077 plus 0.131. That's going to be my bottom number. So out of the not satisfied people, what's the probability that someone is from Glen Falls? So I go back to my chart and I find the Glen Falls people who are not satisfied, and that's going to go on top. All right. From there, part C, we're not going to worry about part C. In fact, that was not supposed to be on the review. So don't worry about part C on either of these questions, but make sure you can do A and B on the next problem. You're going to do exactly what we did here, but I want you to try that one on your own. All right. So remember, you're not choosing out of everybody in A. You're only choosing out of Nebraska people. And then you want that on the bottom. And then on the top, you want people who are going to stay home from Nebraska. Okay. And same thing with B. All right. Let's do, you know what? We're not going to do the geometry questions yet. Let's jump over here to number 11. All right. We're doing hearts, and it wants me to explain what somebody did wrong in number 11 and 12 right here. So we're right here on these two. Number 11 wants the probability of choosing a heart or a face card. Now, if you go back and remember your probability, or means that I'm adding the probabilities together. So this person took the probability of a heart and added the probability of a face card. So that step is correct. They are supposed to add those two together. The problem is you have to remember to look at these two different situations, hearts and face cards. And are there any cards that are both? are there any cards that are hearts and faces? And that there are. There's a queen of hearts, there's a jack of hearts, and there's a king of hearts. So the problem with these three is I counted them twice. I counted them in this group, and I counted them in this group. So to do this problem correctly, you can't just add those together. You have to subtract the ones that you count twice. So it should be 13 out of 52 plus 11 out of 52 minus 3 out of 52. So that's going to be 13 plus 12 is 25 minus 3 is 22 out of 52, which will simplify to 11 out of 26. Okay. Similar problem with number 12. What's the probability that you get a club or a 9? Well, that or means I'm going to add those together. So this person took the probability of a club. Let's keep track of these. Probability of a club is right there. And then they added the probability of a 9, which is right there. Good. But then they added the probability of a club and a 9, because there is one card that is both a club and a 9, but they weren't supposed to add that. This is supposed to be a subtraction. So that's what they did wrong. They used the right numbers, but they were supposed to subtract the card that was a 9 and a club. So 13 plus 4 minus 1 would be 16 over 52 instead of 9 over 26. And then that simplifies to what? 8 over 26, which simplifies to 4 over 13. All right, 25, do we want to get it? Yeah, let's do this side. 25, 26, 11, and 12. Those are plug it in the calculator questions. Using the calculators in class, you should know how to do that. If you don't, then you better find someone to practice doing that before class next time, all right? Remember, on some calculators, there's a probability button, a PRB button. So number 25, I would hit a 5, and then I'd hit PRB, and I would find the NCR button, and then I would hit a 1 and hit enter, and I get my answer. If it's an NPR problem, I would do 9 probability, and then I would hit NPR, and then I would put the 1 instead of NCR. Okay, number 33 and 34. Each year, 64 golfers participate in a tournament. The golfers play in groups of 4. How many groups of 4 golfers are possible? All right, so first thing I need to think about is, does it matter if someone is the first golfer or the second golfer in a group? And it doesn't. It doesn't matter who, it doesn't matter which person you are in the group. So for number 33, the order doesn't matter, so this is going to be an NCR problem. So you're going to use 64 and 4 and plug them in to get that answer. Number 34, you go to a grocery store, it sells 7 different flavors of vegetable dip. You have enough money to purchase 2 flavors. How many combinations can you make? This one's nice because it tells you right there that this is a combination. So this is an NCR problem because the order doesn't matter. It doesn't matter if you buy ranch and nacho cheese or nacho cheese and ranch. It's the same 2 dips that you're buying, right? So this would be a 7 big C with a little 2 problem that you would just plug in your calculator. 37 through 40 want you to decide between using NPR and NCR. And remember, NCR is when the order of something does not matter. It doesn't matter if the object is the first in a group or the third in a group. So to complete an exam, you must answer 8 questions from a list of 10. In how many ways can you complete the exam? So does the order of getting 8 questions matter? And in this case, It doesn't, right? In this case, the order doesn't matter. What matters is that you get 8 correct. So out of 10 questions, I want to choose 8 possible right answers, and the order doesn't matter. Number 38, 10 students are auditioning for 3 different roles in a play. So I know I'm going to have 10 here and 3 here. What I have to decide is, does it matter if these people are picked in a different order? And in this case, it does, because someone getting picked for the first role is different than someone getting picked for the second role, right? So that would be 10 P3. 52 athletes are competing in a bike race. So there's going to be a 52 here. In how many orders can the bicyclists finish first, second, and third? Well, the order definitely matters because first place is different than getting second place. So I'm going to do 52 P3. And then number 40, an employee at a pet store needs to catch 5 tetras in an aquarium containing 27. And how many groupings can the employee capture? 5. It doesn't matter if it's the first one in the group or the second one in the group. It's 5 tetras in a group. So you're going to do 27C5 for that one. All right, geometry stuff. Finally, the fun stuff. No, I really like both chapters in this quarter, but geometry's definitely my favorite area of math. So I really like the geometry section. You might not as much, but it's my favorite, so I can enjoy this part. 11 through 14, it tells me that n is the incenter. So I'm going to actually cross these out because we're not going to use those right now because I forgot to put the triangles that go with them. So 11 and 12, if n is the incenter, so this line, this n right here is my incenter. What that means is from the incenter, if I go perpendicular and draw a line to each side, all 3 of these lines are the same length. So NE is equal to ND and also equal to NF. Those are all the same length. So it gives me some information. It tells me what ND and NE are in terms of X. So I can use that information and this information to set up an equation. I can say that ND is equal to NE, and when I plug those in, that 6x minus 2 is equal to 3x plus 7, and then I can just do railroad tracks to figure out what x is. I can minus 3x's over here, so I get 3x minus 2 equals 7, then I can add 2 to both sides, so 3x equals 9, and then I can divide by 3, so x equals 3. And I get really excited because I'm done, except that I'm not done. And if you don't finish the problem, you're not going to get credit for the problem. This is the first step. But the question doesn't ask me what x is. The question asks me the distance of NF. Well, now that I know what x is, I can find that really easy because I know NF is the same as NE and ND. So all I have to do is take that x and I can plug it into this one or this one. It doesn't matter which one I plug it into. So let's plug it into the second one. So NE equals 3 times 3 plus 7, which is 9 plus 7, which is 16. And since NE is 16, ND is also 16, and NF is 16. So I'm done. Number 12, you're going to do the exact same way. Follow those same steps to do number 12. Number 16 and 15 over here on the right, this one doesn't give me the incenter. This one gives me the circumcenter, which is another point that you really need to know. The circumcenter on these problems, in this one it's P. The circumcenter is the same distance from the corners of the triangle, all right? The incenter was the same distance from, not the corners, the sides of the triangle. The circumcenter is the same distance from the corners of the triangle, but I can follow the same steps. If I know PX, right? PX is this is 4x plus 3. And I know that PZ is 6x minus 11. I know that those are the same length. So I can set up an equation, 4x plus 3 equals 6x minus 11. And then I can solve for x. I can minus 4x from both sides. I can add 11 to both sides. So I get 14 equals 2x, so x equals 7. And once I know what x is, I can plug it back into one of these equations because they're both the same as py. This line and this line are both equal to this line, which is what the question wants me to find. So I'm going to just pick the easiest one to put that into, and I'm going to put it into, let's put it into this one, 4x plus 3. So 4 times 7 plus 3, that's 28 plus 3, which is 31. So P, and I should maybe write, maybe I shouldn't put a check mark. I should say PY is equal to 31. Then I can put my check mark. 15 up here, same thing. The circumcenter is the same distance from the corners. So this length and this length and this length are the same. This one looks a little bit weird because it's a right triangle. So the circumcenter actually lands on the triangle itself. Which happens with a 90-degree triangle. So, all right, moving on. Centroid. So 11, 12, 13, and 14 give me the centroid, and it tells me a few things. It tells me that BG is 6, and that's written right here. It tells me that AF is 12, and that's written right here. And AE, this entire distance right here, AE is 15. Now, there's a few things that you need to know about the centroid. First thing you need to know about the centroid is the centroid is created by going from the corners to the midpoints. So that means this piece and this piece are equal lengths, and this piece and this piece are equal lengths, and this one are equal lengths because those points are midpoints. I also know that where these cross, G, breaks up these lines into pieces that relate to each other. This left piece, this red piece, is twice as big as that blue piece because G is the centroid. So I know that that's true no matter which one I'm looking at. This red line, whoops, that's not red, that's blue. This red line is double the shorter piece. This red line is double the shorter piece. That's true all the way around. So if it asks me to find FC, so let me erase some of this because I'm making a mess. FC is this line right here. Well, I know that F is the midpoint. So FC is the same as AF, which I know is 12. So FC is 12. BF, let's see, where's BF? BF is this entire length right here. So from B to F, I know from B to G, I know this part is 6, and that is twice as long as this little piece. So if that's 6, this little piece is 3. So that means that entire piece is 6 plus 3, which is 9. AG. Let's see. AG is this length right here. And I don't know that length, and I don't know this little length either, but I do know the entire distance is 15. So going all the way from A to E is 15. So I can use a little bit of logic because if A to E is 15, if this line is 15 long and G is in between them, I know that this piece is double this piece. So for example, if this is 4, this is 8. But that doesn't work because those don't combine to be 15. So this piece has to be 10, and this piece has to be 5. So from A to G is 10, from G to E is 5, since those add up to 15, and one of them's double the other. All right, back to other triangles, in-center. So it tells me that N is the in-center, and I think Why are there so many in-center questions on here? Must be because there's going to be a bunch of them on the test. So in-center looks just like 11 and 12 that we already did. You know that these three lengths are the same, so set them equal to each other, solve for x. What I need you to be careful of is when you find x, you've got to remember to plug it back in. So if you're just jumping on the video to get help on these three, rewind and watch how we did number 11, because it's exactly the same idea, okay? All right, moving on. Number 14, the Deer County Park Committee plans to build a park at point P, and it wants to be the same distance from all three X, Y, and Z cities. The map shown was created by the committee. Good job, committee. That is a beautiful map. Which point of concurrency did the committee use? So when I look at this, there's a couple of things I notice. These two hash marks mean that this piece and this piece are the same. So I've got a midpoint right there, a midpoint right there, and a midpoint right there. And those midpoints are connected to the vertexes across from them by these lines. So that tells me which point of concurrency this is. In fact, we used it just a minute ago, right? We used it right here on 11 through 14 because the centroid is the point that you can find that goes from the midpoints to the corners across from the midpoint. So this is going to be the centroid, and you should have good information in your notes about all of these points, right? You need to know exactly what the centroid is and what it means and how you find it. The circumcenter, the orthocenter, and what am I forgetting? Circumcenter, orthocenter, centroid, and the incenter. You need to have all four of those really good notes. Did the committee use the best point of concurrency for the location of the park? If not, which point would have been better? Okay, so they wanted to be equal distances from all of the corners. Where they are located right now, this point P is not the same distance from Y and Z and X. That's not how point P works. What I do know is that point P, this piece is half of this piece, but it doesn't tell me that I'm equal distances from the corners. The one point that is equal distances from the corners we used earlier up here called the circumcenter. Right? When we were using the circumcenter, we found that this point P was the same distance from all of the corners of my triangle. So instead of using the centroid, they should have used the circumcenter because it's the same distance from each corner. All right? Okay, 17, 18, 19, 20. 17 through 19, it gives me a triangle, and it says A, B, and C are midpoints. So A's in the middle, B's in the middle, C's in the middle. So these are the same, these are the same, these are the same. And then it connected those midpoints. So remember this lesson, these pieces are called mid-segments. And they're pretty cool because this distance right here from A to B is half of this distance, GJ. So like AB is half of GJ. Or you could say that GJ is twice as long as AB. And this is kind of the key to doing this problem, at least some of this problem. That equation, that setup right there. So in number 17, it gives me AB. It says it's 3x plus 8, and GJ is 2x plus 24. And it wants me to find the length AB. So I use what I know. I know the relationship between AB and GJ. I know that AB is not exactly equal to GJ. I can either say it's half of GJ, or I can say that 2 ABs is GJ, which I like that one better because then I don't have any fractions. So 2 of the ABs is equal to GJ, and I'm going to plug in those equations that I have for each of those. So 2ab's, 3x plus 8, is equal to a gj, 2x plus 24. Then I distribute and get 6x plus 16 equals 2x plus 24. And then I do my railroad track thing, and I get 4x equals 8. And then I get x equals 2. And some of you are going to stop right there, and you're going to get the question wrong because it doesn't want x. It wants AB. So I've got to use x and plug it back into what I know, AB. So AB equals 3 times x, so 3 times 2 plus 8, which is 6 plus 8. So AB equals 14. Now I can be done with number 17, okay? Number 18 and 19 are similar in that we need to find x, but they are using different information. So it tells me in 18 that A to C, this distance right here, is 3y minus 5. And then it tells me H to J is 4y plus 2. And it wants me to find this piece, HB. Well, let's start by figuring out what y is. And we're going to use that same relationship we used before because I know that AC, if I times 2 of those together, I'm going to get HJ. So 2 times 3y minus 5 is equal to 4y plus 2. I can distribute, and then I can do railroad tracks, and I get 2y equals 12, so y equals 6. So I know what y is, which is a start. It's not my answer, but I know what it is. Somehow I need to use that information to figure out HB, this length right here. Well, I don't know that length, but I know this length, the whole piece, is 4y minus 2. So let's write that. HJ is 4y minus 2, nope, plus 2. And since I know what y is, HJ is 4 times 6 plus 2, which is 24 plus 2, so HJ is 26. But I don't want HJ. I just want half of it. I want HB. So just cut that in half. So HB is just 13. All right, number 19. Very similar to what we just did, number 18, but instead you're looking for GA, and you're going to use GH and CB to solve that one. So give 19 a try, give 20 a try. I think you can figure them out from there. All right, last part of the test review is done on GeoGebra, okay? Make sure you can do the following. Make sure you can draw a polygon, find the midpoints, draw segments between the midpoints and the corners, draw perpendicular lines through the vertex and opposite sides, draw perpendicular bisectors through the midpoints. You need to be able to draw angle bisectors and change colors of objects and change the designs and thicknesses of lines and points and names. If you don't know how to do that because you didn't finish GeoGebra as part of the lesson, this would be a great time to go back and do the intro to GeoGebra. It's going to teach you how to do all of those things on that video. So make sure you know how to do those because that is going to be part of the test. If you need help, come see me before school, and I'll do what I can to answer your questions, help make sure that you're ready for that test. What I would recommend from this review is that you add whatever you need to help you solve the problems. Don't write everything down. Only write down what you need to help you solve the problems that you saw on the review and needed a little bit of extra help with. All right, good luck.